Technology for binomial probabilities. Now, this topic of using a normal distribution to approximate a binomial distribution was once quite important, but we can now use technology to find binomial probabilities that were once beyond our capabilities. For example, see the accompanying stat display showing that for the first example, the probability of 152 or more yellow peas is 0.2650. And for the second example, the probability of exactly 152 yellow peas is 0.0301. So there is really no need to use a normal approximation. However, there are cases where we need to use a normal approximation, and the future section uses a normal approximation to a binomial distribution for an important statistical method introduced in that section. Now let's just see how you would do this on StatCrunch, because this is StatDisk. So if we open up StatCrunch, all right, and if we were using the binomial calculator, in the previous examples we converted it to a normal distribution, but if we go to the binomial calculator, what we're going to do is we're going to put in the value of n. Well, the value of n is how many trials, and the trials were 580. So if we put 580 in here, and then put in the probability of success, which is 0.25, and we were looking for the value of 151.5 or more. So that gives us 0.26495583. That's what we were looking for when in the first part. Now, the second part is we wanted to find out, and you can see here this matches our value over here, 0.2649558, because that's considered as 152 or more, but we started with 151.5 or more. Now let's go between. Now if we wanted to go in between, remember in between would have been exactly 152, which means we have 151.5 here on the left, and then 152.5 on the right. And therefore we would select compute, and you see we're going to get 0.0301231. Again, that's using the binomial calculator. Now keep in mind what we've done is we converted it to a z-score. So instead of using the binomial calculator, we came in and then used the calculator for the normal distribution. So the normal distribution we then converted to a z-score. And so we wanted to find out what it would be like if it was going to be greater than 0.62. And that gave us 0.2676, which is slightly different than what you're going to see over here. Okay, and then we also wanted to use the normal calculator to find it in between 0.62 and 0.72. And that gave us 0.0319, which again is a little bit it's close to what we get for the one here using the binomial calculator. But again, what we wanted to do is we wanted to then use a normal approximation so that we can use the normal calculator by converting them into z-scores.